This essay example, as well as thousands of others, is available in text format on our website for free and without registration. Simply Google IVPanda Free Essays.
Intel Core i5 is a family of 64-bit x86 processors with mid-range performance developed by Intel for laptops and desktops. The Core i5 was introduced in 2009 by Intel to succeed the Core 2 families. Therefore, this family is found between low-end and high-end performance Core i3 and i7, respectively. Core i5 processors contain 4 cores with features like Turbo Boost technology. According to Intel, Core i5 processors are grouped into generations depending on the microarchitecture, like first-generation Nehalem and Sandy Bridge. The increasing need for performance from personalized computers has spearheaded the generation of Intel microarchitecture. Sandy Bridge has an advanced memory controller and increased processing power, making it more advanced than its predecessors. Processors instructions set architecture lengths and format. Processors implement instruction set architecture, ISA, that specifies a set of instructions that are linked with machine language. In the current computer generation, the most common ISAs are IA32 and Intel 64. The IA32 and Intel 64 architecture instructions constitute instruction prefixes, a maximum of 3-byte principal opcode bytes, addressing form specifier containing mod r/m and scale index base byte, an immediate data field, and displacement. There are 4 instruction prefixes: lock and repeat forming group 1, segment override, branch hints, and bound prefix in group 2. The third group comprises operand size override prefixes encoded using 66H, while 67H, an address size override prefix, forms the fourth group. Primarily, opcodes can have 1 to 3 bytes, and in the mod r/m byte, there can be an encoding of an additional 3-bit opcode field. In the primary opcode, smaller fields are defined to show the direction of sign extension, condition codes, register encoding, displacement size, and operations. Operation class determines the encoding fields and varies based on the opcode. The mod r/m byte comprises a mod field that aggregates the r/m field to create 24 addressing modes and 8 registers, and reg/opcode that specify the number of registers and opcode information. In addition, the r/m field specifies registers as operands and combines mod fields to allow encoding in the addressing mode. Second, addressing bytes are used in the scale plus index forms, and the base plus index includes fields such as scale fields that act as scaling factors. The index field signifies several registers for index registers, and the base specifies base register numbers. Displacement in addressing forms that follow the SIB byte or mod r/m byte must be either 1, 2, or 4 bytes. Instructions that specify immediate operands are followed by displacement bytes. Currently, the AVX instructions length does not exceed 11 bytes in length. However, in Intel 64 and IA32, the maximum length of instructions remains 15 bytes. Processor's CPU execution components. CPU refers to the processor package on a typical motherboard with RAM and system clock not forming part of the CPU. The execution components of processor CPU include ALU, cache, RAM, hyperthreading, supercharging the instruction cycle, CPU clock and control unit, memory management unit, an instruction register, and pointer. The arithmetic logic unit, ALU, performs the logical and arithmetic functions of the computer. The computer registers A and B holds input data while the accumulator receives the operation result. All the instructions executed by the ALU can be found in the instruction register. ALU also performs an address-in-memory operation that involves calculating a new location in memory to start the loading of instructions, after which it is placed into the instruction pointer register. An ALU contains numerous input and output nets that convey digital signals between it and external circuitry. An ALU comprises 3 parallel data buses, 2 input operands, and an output giving 1 binary integer number. Opcodes specify the desired logic or arithmetic operations an ALU performs, and the opcode size determines the maximum number of ALU operations. Status signals of a general-purpose ALU include carryout, zero, negative, overflow, and parity. These statuses are stored in external registers to allow ALU to access future operations when implementing multiple precision arithmetic and controlling conditional branching. The arithmetic operations of an ALU include addition, subtraction, add with carry, subtract with borrow, pass through, decrement, increment, and negate or two's complement. However, bitwise logical operations entail and, or, exclusive OR, and one's complement. The operations carried out by ALU can result in bit shifting from left or right based on the opcode. Thus, the bit shift type can be through carry, rotate, logical shift, or arithmetic shift. Processor's pipeline stages. Pipelining entails the accumulation of the processor's instructions through a pipeline to allow instructions to be stored and executed in an organized process. During execution of instructions, multiple instructions can overlap during pipelining. It is categorized into stages, which are interconnected to create a pipe-like structure. During pipelining, total efficiency is achieved by passing instructions from one end and exiting it in another. There are two processor pipelines, an arithmetic and instruction, and a 5-stage instruction pipeline for executing RISC instruction set. The pipeline stages are instruction fetch, instruction decode, and instruction execute, memory access, and write back. Instruction fetch forms the first stage in which the central processing unit reads instructions from the memory address containing values in current program counters. The instruction fetch stage does PC+4 calculation and predecode for register file read, and it is where the next instruction fetch is performed. The second stage is instruction decode, where instructions are decoded and the file register is retrieved to acquire the register values used in the instructions. At this stage, hazard resolution and data forwarding are also carried out. ALU operations, branch resolution, memory address calculation, and CSR read-write are done in stage 3, or the instruction execute stage. In the memory access stage, the memory operands are written and read to or from memory existing in the instruction and branch redirection. At the write-back stage, the computed or fetched value is written back to the register available in the instruction. Therefore, the write-back stage enhances data dependency resolution by offering general-purpose register values. The pipeline can stall because of data dependency and resource stall. Data dependency occurs when the source operand is unavailable in the decoding stage and instruction in the decode stage and fetch stage stalls until it becomes available. The pipeline stalling can occur if the general-purpose destination registers multi-cycle or load instructions in the execution or memory stage and becomes the source for the instruction decode stage. In addition, a resource stall occurs if the multi-cycle or memory operation is performed during the instruction memory stage. The instructions in prior stages stall until the memory stage concludes the instruction set. If you want to find more works like this essay on processor Intel Core i5 and its features, head over to ivpanda.com. It has a collection of samples with thousands of submissions covering virtually all academic subjects.